The right answer is Bj is going up and Bj is not going down. Let me explain to you why. Okay. If you put your finger down here, or if you were to pin down here, right? We know that P, right? P over here will induce a moment which is P multiplied by 4 plus 4. Okay. If we assume Bj to be coming down, what will happen is Bj that is coming down will induce a Bj multiplied by 4, both coming down. So when that is the case, the member AB will what? Rotate. Okay, member AB will rotate. But we have to prevent it. We have to prevent the rotation. Why we have to prevent the rotation? Because in real life, this structure over here that you see in this diagram over here will not rotate. Why it will not rotate now? Because if we assume Bj that is going up, what will happen is going to counter the moment, and this is equal to Bj multiplied by 4. The Bj multiplied by 4 will counter the P4 plus 4. That is why Bj is going up. So once you know this, okay, then you start drawing a line. Okay, you start drawing your green line again. Okay, and you have the vector form. If this is Vj, okay, then we know that this direction is your Bi, and pointing towards here, this is your B, right? Your B. Then action equal to reaction. This is your not B, sorry, your I didn't call it, yeah, I didn't call it anything. So action equal reaction. This is your member over here. This is your member BC. Action equal to reaction, same in magnitude, different direction. This is also in what? Compression. Okay. So either way you do it, the answer will be the same, but just a different perspective. One is given, I know, given the question over here, I'm aware that it's going to be buckling because BC will buckle. Buckle is compression. If not, if you are not sure, because sometimes the question will not tell you the answer, the question in general in engineering problem, they will not tell you whether the structure will buckle or not. You have to analyze. Okay. When that is the context that you have to analyze, you have to find the reaction force. So you have to use this method over here. Okay. Remember, in real life, you are not given this sort of information at all. Right? In real life, you're not given this sort of information. In real life, you are given this diagram. Find P. This is the material to use. Let me know what is the value of P. Are we clear? Okay. So now we know that how it will behave now. So now we would like to find our not find our reaction first. We want to know, okay, how does the two axes play about in getting our critical load? Okay, so on this problem again, the formula that we are going to use. So did they give us safety of factor? No, no safety of factor given. Fine. So we know that PCR formula is still the same. Pi squared E I over L E squared. Okay. Now I'm going to take this diagram. Okay, we're going to analyze this diagram now. Okay. No diagram. Let me take it from here. Okay. So we are going to analyze buckling. Okay, we're gonna, so if this is the X, okay, so coming out, I'm going to, so what it states down here, coming out over here, this is our, or this dot, or for the above, the dot is our X. This will be our Z, right? Dot is X. No, that is our Y. And using right hand rule, this is our Z. Okay. So now let's look at what will happen on the YZ plane. Okay, let's look at what will happen on the YZ plane. So on the YZ plane, right? So it looks like this. Right? So this is our point C and point B. And we realize that both ends are what? Pin. Okay, i.e. the moment is equal to 0. Right? Because if you remove the support at C, BC will rotate. If you remove the support at B, right, C will, or when you remove support at B, you take this piece out, this thing will rotate. So moment is equal to 0. So in the XY plane, as you can see down here, our equivalent length is equal to L. Okay, our equivalent length is equal to L. Okay, so that is our XY plane. Now, if we now look at our XY plane, so initially that is for our YZ plane. Okay, then now we look at our XY plane. Okay, now XY plane, now the structure look like this. Okay, I'm drawing the structure. Right? So we have the pin going through. So we have the other part that is fixed onto here, right? We have the other part that's fixed onto here. And then we have another part that's fixed over here. Right? And then we have a pin going through, another pin going through. Okay. Now, because of this flat region over here, the moment is not equal to 0 now. It prevents it from what? Rotating. And then the moment is not equal to 0. So when that's the case, one end is fixed and the other end is also what? Fixed. So therefore, the LE now for both ends that are fixed is, or not, not 2L, impossible. This is equal to 0.5 L. Okay. So just to get you the diagram, both ends are fixed. Okay. For one and the other one, both ends are pinned. Okay. So for this case, both ends are pinned. Okay. So LE is equal to L. Right. Both ends are pinned. Both ends. So now you see the importance, okay, the importance of able to identify the boundary condition. Okay, so I'm going to proceed with calculating. Okay, we're going to start with the YZ plane first. Okay, before we do our YZ plane, let me get the big picture. So we still don't know our length. We still don't know our length BC. Okay, so BC will be equal to 3 times 12 squared plus by 4 times 12 squared. The 12 over here is to convert feet to inches. Okay, why we have to convert to inches? Because our Young's modulus is pounds per square inch. Okay, so 3 times 12 squared plus by 4 times 12 squared. Everything square root is equal to my equivalent. Wait. 3 times 12, or bracket 3 times 12 squared plus by 4 times 12 squared, square root the whole thing, is equal to 60 inches. Okay. So if we were to consider, again, we still don't know our I value. Okay, so let's our BC first. So we know that when we consider the YZ plane, we know that PCR at the YZ plane is equal to pi squared E IX. We are looking at YZ. Let me I forgot my transformation. The transformation is very important. Yeah, if you lose the transformation, we are in trouble. I mean, I'm in trouble. Okay. So this is our transformation. So it's equal to Ix over by our LE squared. Okay. So first we have to determine our Ix. So Ix, so XX direction, we know that this is the axis of interest. This will be the width. Okay, so I'm going to draw the cross-sectional view now. Okay, so this is the XX. So we know that this will be the width and this will be the depth. And the width is 1. And for this case, the depth is 3. Okay, so from here, Ixx is equal to 1, 3 cube over 12. So 1 times 3 power 3 divided by 12 is equal to 2.25. So from here, we can calculate our P critical is equal to pi squared. Young's modulus is equal to 29 times 10 to the power 6, 2.25. Okay, and then divide by our equivalent length, which is 60 squared, because LE is equal to L. Right, for this case, LE is equal to L is 60 squared. So this will be equal to 3 pi squared times by 29 power 6 times by 2.25 divided by 60 divided by 60 is equal to 178.887 times 10 to the power 3 pounds. Okay. And I'm going to do the other axis also. So the other side is PCR. And the plane is what? The plane is the XY plane. And this is equal to pi squared, or just put XY. So this will be equal to pi squared E. Now it's IZ. Okay, IZ, and then this is divided by our equivalent length squared. So our IZ So this is our ZZ axis. Okay. So the ZZ axis, so the width will be equal to 3. The depth will be cubed divided by 12. Okay. So 3 divided by 12 equals 0.25. So from here, our PCR for our XY plane, the one before we calculate is the PCR. I'm almost done, okay, for the YZ. So this will be equal to pi squared, 29 times 10 to the power 6, times by 0.25. This is the inches to the power 4. And we know the denominator is the LE is 0.5, okay, multiplied by the length, which is 60, and the whole thing what? Squared. Because this is both ends are what? Both ends are fixed. So our critical load now is equal to shift pi squared times by 20 power 6 times by 0.25 divided by 0.5 divided by 0.5 divided by 60 divided by 60 is equal to 79.51 or 51 times 10 to the power, it's not 51, it's 505 times 10 to the power 3 pounds. Okay, so what will happen is buckling will occur at 79.505. Okay, now you pick the what? You pick the lower load. Okay, I do apologize going over by 1 minute. I'll see you guys tomorrow at 7 o'clock for 1 hour. Thank you for your time and don't be too stressed. Bye. See you guys. Bye.